Hi, welcome to question 2 of try now 39. I think that is on page 508 in your y equals mx plus c textbook. If you don't have the textbook, I think you can just as well follow. It says the parametric equations of a curve are x is equal to t plus 1 multiplied by e raised to t. So that is x equals to t plus 1 multiply e raised to the t, and the other one is y equals to 6, and then in brackets we have t plus 4, and it's raised to the power of a half. Good. Now they are saying find the equation with the tangent, so we need to find dy dx because of the equation of the tangent of the curve when t is equal to 0. In fact, we can actually find the value of x and the value of y if t is equal to 0, then x will be, okay, maybe just to play around with the color coding. So then x will be 0 plus 1 e to the t, of course 0 plus 1, then x is nothing but t, sorry, so also this t here should be equated to 0 everywhere you have a t. Okay, everywhere you have a t, you're gonna have t there, if t is equal to 0. So yeah, that is just going to be 0 plus 1, that's 1 times 1, so x is going to equal to 1. Similarly, y will be 6 in brackets, we have got 0 plus 4 raised to the power of a half. Now, if you know that anything raised to the power of a half is the same as taking the square root of that, so the square root of 4, this is the same as 6 times 2, which is 12. So I have my point that I will be considering in my equation, okay, and the point that I'm going to consider is the point x is 1 and y is 12. So this will be my x sub 1 and it will be my y sub 1. Okay, really important that I get back to this point because I'm going to use that point. Right, so I know now what my point is, but we will be writing our equation. So we need to find our gradient, and then when t is equal to 0. So let's then find a gradient. So if I have to write it here, I have the first one, we've got x equals 2, because we're going to use the chain rule. So we've got x equals 2, t plus 1, e raised to the t. We have y equals to 6, and then you have got t plus 4 raised to the power of a half. Okay, what are we looking for? We have dx dt. Okay, so here we're going to apply the product rule, of course. Keep the first, so t plus 1 multiplied by the derivative of e to the t, which just happens to be e to the t. Then keep the second, multiply by the derivative of the first one, and the derivative of the first one is just going to be equal to that. Okay, so if I have to clean this up, this is going to give me nothing but e to the t. So this is nothing but I have got t plus 1 e to the t plus e to the t. Well, of course, I can take out e to the t, then have t plus 1 inside my bracket plus 1 over there. Then this cleans up nicely to e to the t, and then inside I'm going to have t plus 2. Okay, this is dx dt, but we are looking for dt dx, so it's just going to be 1 over all of that. So that's e to the t and t plus 2. Right, so we're done with that one over there. So we are going to do just make this a little bit smaller for now, just to bring in my line. You can separate the two nicely. So I'm now going to look at this one. I'm done. So I'm going to use this one, obviously, for the next scenario. Right. So we are going to look for the y dt. So dy dt. Now, there's quite a number of things you can do when you are looking for dy dt. Of course, you can use the chain rule and so on. This is dy dt. So we're going to have that 6 times a half. Then you keep in the brackets, you keep t plus 4. Okay, now this is going to take away 1, negative a half. And then you're going to multiply this stuff by the derivative of t plus 1, which just happens to be 1. Okay, so at the end of the day, you have got 3, and then you have t plus 4 raised to the negative a half power. Now, it can be written as 3, all of this can be written as 3 all over t plus 4. When something is raised to the power of a half, it can actually be cleaned up further, and you can write it as dt, dy dt. So dy dt is nothing but 3 all over the square root of t plus 4. Okay, right. So this is actually working nicely in our favor. We have these two, and we are going to use the chain rule to sort of multiply those two. So by the chain rule, dy dx, so oopsie, so dy dx is equal to dt dx, or dy dt, which is going to be that 3 over t plus 4 multiplied by 1 over e to the t, and then you have t plus 2 over here. Well, I'm just going to leave it over there. So what we need to find is the gradient. We need to find the gradient of dy dx at the point where t is equal to 0. That is going to give us 3 all over square root 0 plus 4, okay, times 1, remember t is 0, e to the 0, and then, okay, that bracket doesn't look so nice, so let's just bring that bracket and make it nicely again. So I don't know if that is nice, but 0 plus 2. Well, of course, if you were to play with all of this, you're going to have 3 over 2 times 1 over 2, which simplifies to 3/4, which is the gradient now. The gradient is equal to that. Okay, so the gradient is equal to 3 over 4. Okay, see if I have another page that I can insert. Right, so remember from our beginning work right in the beginning, our point, I remember it was something of a 12, I think it is 1,12. Our gradient is 3/4. Let's just make sure about our point. Okay, and we're looking for the equation of what is the tangent and normal. So they're looking for the equation of the tangent. Good. So our point was, yes, 1/2, as you can see there. So we can now actually continue, and they also want it in the form ax plus by plus c is equal to 0. Very important that you take note of that. Okay, very important. So go back, read the stem, and don't just grab and rush through the answers. What is it that they are looking for? Equation of the normal or equation of the tangent? In this case, they're looking for the equation of the tangent. And they're just not looking for it in any other way. You're supposed to give it in that form. Right. So using our formula, that by now it should be part and parcel of your, DNA, that is y minus y sub 1 is equal to m, and then you have x minus x sub 1. Right, so the point over here, that will be our x sub 1, and that point will be our y sub 1. So y minus 12 is equal to the gradient, which is 3/4, and then x minus 1. Of course, you can actually go ahead and you can put the y minus 12, you can put y minus 12 in brackets, right? So I'm going to put that over in brackets. I'm going to multiply that by that 4. Y minus 12 is equal to that, and that is 3, and then x minus 1. So we're going to distribute. You have 3x minus 3 over here. You have got 4y minus 48. Now 48 being 4 times 12. Right, so I'm going to move all the terms on the left to the right. So this is going to be not equals to 3x. When you bring that over, it becomes minus 4y. Then, of course, remember, I had a minus 3 here. And when I bring that 48 over, it's going to be plus 48. Eventually, if you have to clean this up, you'll have 3x. So therefore, 3x minus 4y then plus 45 is equal to 0. Your textbook might have a small error if you are following your answers there. So hopefully this can also serve as the correct version of that. Okay, so this is definitely the solution, and they wanted it in the form ax plus by is equal to ax plus b, this one, ax plus by plus c is equal to 0. So your equation should be in that form. Okay, and obviously it checks out. A is 3, B is negative 4, and C is 45, and that is what they were looking for. Good. We're going to look at 2 more of my series on parametric differentiation. Hopefully this is very helpful as you prepare for your studies.